Hello students. So this is in continuation with the previous video session that we saw. In the previous video session, we saw how to insert element in the single linked list. We saw insertion at the beginning. We saw insertion at the end. Right. So today let us see how we can insert at a particular position. In the last, there are two things that you have to understand. One is how to insert at a given position. The other one is insert before an element. These two are the things that we are going to see now. How to do insert at a given position and insert before an element. Means what? Let us try to understand the difference first. Let me tell this is the, let me take an example. This is a linked list that I have. So this is a linked list that I have. Okay. Now, when I say insert at a given position, this is the first node, this is the second node, the third node and the fourth node you have. Now when I say insert at a given position, suppose I say 2. I am not taking these data elements, okay, but I am going to give the positions. When I display my linked list, it will display like this, 31, 23, 14, 50. This is how it displays. So when I say the position means, let us say I am saying second position. Second position I want to insert, my element is 55, let us say, assume that. So that means when I say second position I want to insert, I should have something like 31, 55, 23, 14, 50. This is how my linked list should look. That is what we mean by position when we say you want to insert at a given position. So when I say first position, if I say for position is 1, what it should do? It should do before the 31. Before 31 it has to display. Now insert before an element means what? That time I am going to specify these values. I want to insert before 50. That is what I mean when I say insert before an element. When I say insert before an element, you should ask for which element before which you want to insert. When I say insert at a given position, I can only give either it is a first position, second position, third or fourth or whatever it is. When I say before an element, then it should, we have to specify either of these. Then there can be also a condition where the given specified element is not present, so I can't insert. Okay, so that is a difference between insert at a given position and insert before an element. Let us see how we can code both of these. Okay. Now let me start with insert at a given position. First we'll do that. Now these two are there in your lab program, that's why we'll have to do that. So we have taken a class called single linked list. Okay. Now how do I insert? Okay, I will use a scope resolution operator. Insert, I am starting with insert at a position. Insert at a position. Right? Okay. Let me see what can I declare. I will take one variable called value. I will take position. One more looping variable I, counter. I will take one counter. I will tell you why I am taking. I will initialize this to 0. Okay. Now first let me accept at what position I want to insert. Alright. So I will write, let me put it as cout. Okay, let me take first what is the value I want to insert. Insert the value to be, enter the value to be inserted. What is the value that I want to insert? That I should accept first, is it not? So, I will write cn value. Next. Let me keep my node ready. If I say in the last video we saw, let me call my node as temp. So I keep this node ready. Okay, whatever value I am going to insert, that value will be coming here. This I will take it as null. That's my node is ready. So how do I code that? I will take node star temp is equal to new node. That means new we are using so that it allocates the memory to this value. So then temp of data, we have two fields. This is my data field and this is your next field. Temp of data will be equal to whatever I have accepted, the value that I have accepted to be inserted. Okay. Then temp of next is equal to null. Right. So that means this part indicates that my node is complete. It is ready in all respects. Now what I should accept? I should accept at which position do you want to insert this particular node. This node is ready. I have to insert at a point. So at what position I want to insert, that I should accept, is it not? So see out. Enter the position. Enter the position at which node is to be inserted. Okay. So I will accept this. Cin, I have declared one variable called position. So I will accept that position. So POS indicates where I want to insert. Okay. So this is the initial part of the code. What we have done? We have taken value, position, I counter. Counter is equal to 0. I will tell you why I have taken that. Then I have inserted, I have accepted what value I have to insert, Cin value. Then I am keeping my node ready. My node is ready with the value, okay, to be inserted. So that node I call it as temp. I am allocating memory for that. Temp of data, whatever value I have accepted, I put that value inside that. Temp of next is equal to null. And then enter the position at which the node has to be inserted. Right? You have to insert it at a position. So I should also accept what is the position at which I am going to insert it. So I am accepting this position. Is this clear? This much is the initial coding that we do. Next, let us see what are the conditions you have to consider or how to insert at that position. Let's see that. So after that part of the code, let us see how we can consider. Let me take a small example of my linked list. This is the linked list that I am having. Let me tell you that. Okay. Now, if I want to insert at a particular position, the position can be 1. 1 means I have to insert it before the first element. The position can be somewhere, this is my 1, 2, 3, there are 4 nodes. So position has to be 1 or 2 or 3 or 4, correct? You cannot have any other value. So, whatever position you have entered, you have accepted Cin POS, is it not? This POS value should either be 1 or 2 or 3 or 4 only. If I say 5, then that is wrong, correct? So, that means I need to know whether the position that I have entered is within this range or not. How do I find out that? For that, I should first identify how many nodes I have. So if I have 4 nodes, then the position also should be 1 or 2 or 3 or 4, it is right. If I have only 4 nodes but the position is 5, then I should be able to check that 5 is out of range, correct? So that is the reason I need to know first how many nodes are there in the linked list. First let us do that part. Let me take, okay, assume that I have also declared 2 more pointer variables, node star s and star pointer. These are the 2 more variables, pointer variables that I am declaring. First, I want to count the number of nodes. How can I count? Let me take s is equal to start. So this is the start I have here. This is the start. Start is pointing to the first node. S is equal to start. Okay. I want to count the number of nodes first. While S is not equal to null, what do I do? S is equal to S of next. That means I start from here. S is equal to start. S of next is S is not null. So I will go. This will be S is equal to S of next. So this will become S. S is not null. So this will become S. I will go on doing. As I do that, I am going to increment this variable counter. Why I am doing this? What do I get after this? By the end of this, when my last node is null, I will be getting counter value as 4. This indicates to me what is the number of nodes that I have. Why I need to know this? Because the position POS value that I have entered should always be within the range of the number of nodes. If my number of node is only 4 and if position if I enter it as 10, that's wrong, is it not? I should be able to check that part. That is the reason I am taking how many nodes are there in the linked list. Okay. So now we know what is the number of nodes. That are. Now let us start. If position is equal to 1, what does that mean? I want to insert at the first position. I want to insert at the first position. If my linked list is like this, then my new node should come before this. That means that should become the first. This will become second, third, fourth, like that. Correct? Now, if it is position is 1, before I do this, I should also check. My linked list could be like this, wherein I will put it before this, or it could be empty. I don't have any nodes at all. In that case, whatever I am entering will be the first node. So then what I will do? I should check for that also. If position is 1, and how do you check for empty linked list? If start is equal to null. Okay, because what I am checking? First position, but the linked list is empty. Then the node that I am going to insert itself will become the first node. So what will happen? Start is equal to 10. We have seen this insertion at the beginning. Same code we have to write. Start is equal to 10. Start of next will be equal to none. This is same as what we wrote for insertion at the beginning. Are you remembering? Last video we had done that. Else. Else means what? I want to insert at the first position, but the linked list is not empty. Something like this. It is already some nodes are existing. So what will happen? My new node will come here. And that new node will become the new start. Correct? So else what can I write? I'll write here. Temp of next. The new node will come here. This is my new node, temp. Right? Temp of next should point to start. Start will become the, temp will become the new start. That is how we should implement. Temp of next is equal to start. Start is equal to temp. This is you are trying to do at the, if your position is 1. If you want to insert at the first position. If your position is 1, first thing you are checking is whether the linked list is empty. If it is empty, that new node will become the first node. If it is not empty, something like this, that is your nodes are already existing in the list, then your 10th node should come because I put a position as 1. I want to make this as the first element. So it will come here. So temp of next will become start. Temp will become the new start. Okay. That's how we do. Okay. Next, what is if the position is not 1? That means I don't want to insert at the beginning. I want to insert elsewhere. Then what I will do? So this if this if gets over here, I will take next one more else. Now else if Position is not 1. Now we have done for the first. If my position is 1, what to do? We have done it. Next what I check, if position is greater than 1. And greater than 1 means, now how many nodes I have? 5 nodes I have. Correct. Now, if you are trying to say position is, you enter the position, you have already accepted POS, is it not? If you have accepted POS as 10, then that's wrong, is it not? So, that is the reason we have counted the number of nodes. If POS is greater than 1 and POS is less than or equal to counter. Counter is what? The number of nodes that you have identified. What will happen? S is equal to start. So, let us say my position now is 3. Position is 3 means it is greater than 1. It is less than or equal to counter. Counter is nothing but the number of nodes, total number of nodes. So, now let us assume my position is 3. That means I want to insert at the third position. So, I have to traverse up to this. What will happen now? This new node will not come here. M is my new node. Some value we have inserted, we have accepted. So, I want to bring this temp at that position, third position. Okay. So, what will happen? This will come here. This has to come here. That is what you have to change. This will go. This will go. This arrow will go. The temp of next has to go to this element, which will become 4 now. Next of this node should be connecting to temp. That's how I insert at that position. But for that, I should move up to this location. I have to come up to 3. Is it not? So what I do, I will take one pointer S is equal to start. For I is equal to 1, I less than pause, I plus plus. Pointer is equal to, I will take one more pointer, pointer is equal to S. S is equal to S of next. 2 pointers I have taken. Why am I doing this part? Because I want to come up to that particular location. Correct? So how do I come? I have taken this as yes. So I is equal to 1, I less than pause. What is my pause? 3. Because I want to insert at the position 3. I plus plus. Till there what I do? Pointer is equal to S. S is equal to S of next. So this will, when I start with this, pointer is equal to S. So this will become pointer. This will become S. Similarly, this will become pointer. That I am going on traversing each of them until this condition is met. I less than pause. So when I stop there, node number 2 will be my pointer. Node number 3 will be my yes according to this. So I know now where I have to, because I need to know these 2 pointers before I insert at this position. I have to access this and this, is it not? How will I get to know that? That is why I have made use of pointer and yes. So how can I write now? When I come out of this, second node will be my pointer, third node will be the yes. Okay. So what can I write here? Pointer of next. This has to come to your temp, is it not? What is this? Pointer. So pointer of next will be equal to temp. Temp of next will be this node. What is this node? Yes. So temp of next will be equal to yes. Okay. That is how you insert at that position. Else I have to take one more else condition. What is it? If this condition is not satisfied. That means, as I said, you have only 4 nodes, but you have entered your position as 10. That means it's out of range. Correct? That also you should write. So, see out, else, I'll write it here. See out, position out of range. You can't insert because you have entered a wrong position or it is out of range. Let's say in here and then this option ends. So that is how you insert at the position. So what we did first, we counted the number of nodes. Then if the position is 1, what we did, and we also checked if the linked list is going to be null. If it is null, then the new node itself will become the first node. If your linked list is null, new node will become the first node. If linked list is not null but you want to insert at this position, it is same as insert at the beginning. So we have done that. Next, what we are checking, if it is position is greater than 1. It is not sufficient if you simply check greater than 1. We should also count, see to it, it is lies within this range. It is less than or equal to counter. Counter is nothing but the number of nodes that you have in the linked list. So if we are doing that, I want to traverse up to that position where you want to enter. That is why we have taken this. 2 pointers we have taken, pointer and yes. Pointer is equal to yes, yes is equal to s of next. So I go on traversing until I reach that point. Once I reach that point, I know I am able to access this, I am able to access this. This is my pointer variable, this is yes. So pointer of next, which is this is your pointer. Pointer of next should be pointing to your temp because your temp should come at this position. Temp of next should go to yes. That is what we have written. Else means what? Position may be greater than 1, but it is not less than or equal to counter. So you will write it as out of range. So this is how you try to insert at the you try to insert at a particular position. So next we will see how we can insert before an element. How we can insert before an element. Okay. I will see you. I will take this up in the next video session. Thank you.